Netsparker, the developers of desktop and cloud-based web application security scanners that enable you to automatically identify vulnerabilities in your web applications and web services. Netsparker scanners employ a unique and dead-accurate vulnerability scanning engine that automatically verifies vulnerabilities with their proof of concept. For more information, visit them on the web at netsparker.com or email at contact@netsparker.com. Recorded Future. They help security teams make more confident decisions faster. Recorded Future's technology automates broad collection and analysis of cyber threat data and delivers the rich external context you need to understand alerts and emerging threats. With real-time threat intelligence from Recorded Future, security teams respond to threats 63% faster and find undetected threats 10 times quicker. To get started, go to recordedfuture.com/Security Weekly and sign up for the Recorded Future Cyber Daily. Every day, you'll receive an email with the top results for trending technical indicators, cyber news, exploited vulnerabilities, suspicious IP addresses, and more. Subscribe today and stay ahead of cyber attacks. Endgame's converged endpoint security platform is transforming security programs, their people, processes, and technology with the most powerful endpoint protection and simplest user experience, ensuring analysts of any skill level can stop targeted attacks before information theft. Endgame unifies prevention, detection, and threat hunting to stop known and unknown attacker behaviors at scale with a single agent. For more information, visit endgame.com. Welcome, everyone, back to Security Weekly. I should say that was a great interview, of course. It was pre-recorded with Philippe and Sumed. This segment, we're going to start off with a couple of announcements. Exciting news about Security Weekly webcast program. We're partnered with ISC Squared as an official CPE provider. If you attend any of our webcasts, you will receive 1 CPE credit. That's right, 1 CPE credit per webcast. You can register for upcoming webcasts with Core Security, ServiceNow, and someone else. Great Horn. Yep, those are the 3 that are coming up. And you can also register for and view webcasts in our on-demand library and receive CPE credits for those as well. It's very easy. You go to securityweekly.com, you click the webcast menu, and you can choose from upcoming ones and on-demand. We are also running some surveys. Are we still running the listener survey? I would imagine that we are.
Yes,
right? We're running
we are.
2 surveys. Yeah, 2 surveys right now. One is asking how mature is your process automation for various security capabilities. That is the 5 stages of automation maturity survey, which we'll be doing a webcast in November where we'll analyze the results. So get in there and fill out that survey and tune into the webcast in November. We are also doing our annual listener survey where we want to hear from you. We want to know a little bit about you anonymously. And also we use that information to shape the content on the show. So this is your chance to voice your opinion on what kinds of content and how you want to consume that content and all kinds of things like that at securityweekly.com. Click the survey link on the main page. It is a menu and you can choose. Let's see. With me here on this segment, of course, Security Weekly CEO, Mr. Matt Alderman is here. Matt, welcome.
Merry Christmas. Happy Halloween.
Hanukkah? No. Yeah, Halloween.
No,
I know.
I've got like 4 inches of snow outside. It might as well be Christmas.
Oh, I see. It's raining here on Halloween, which is kind of a bummer. But right now, it's not raining too bad. So hopefully, it holds out. Also, we're all remote for this one, which is very, very strange because it is Halloween. It was not in studio today. So this is some of you may remember the old Stogie Geeks studio. This is the new version of the Stogie Geeks studio that we've resurrected, which is also serving as my man cave and a remote broadcast studio. Also on the lines remotely, Tyler Robinson is here with us. Tyler, welcome.
Hola. Good afternoon.
And Tyler, you're a something of something at Nisos, right? What is your title at Nisos?
Let's see. What is it now? Managing Director of Network Operations, I think.
You are
the guy
wizard
that does a lot of stuff.
Yes, it's awesome. Let's see. So here with us for this technical segment is Sven Morgenroth. Sven is a security researcher at Netsparker and has some really, really awesome information to share with us today about format string vulnerabilities. Sven, welcome to the program.
Thanks for having me again. It's always great to be here.
Yes. And now, format string vulnerabilities are nothing new, but I think the way in which these are accessed is what makes these new, correct?
Yeah, so we actually took a look at a lot of different languages that you would use for web application programming, for example. And we took a look how secure their format string implementations are. And there are some surprises. I will first start with a quick explanation of what format strings are and why they are dangerous. You might know them from the C programming language. They are quite they have been quite prevalent there. And yeah, so I've prepared a little presentation, and I can share my screen with you now.
Sweet.
So just a second. All right, can you see it?
Yes, sir.
Yes.
Okay, great. So we'll start the presentation now. It's called The Dangers of Format Strings in Web Applications. And I'd like to begin with what format strings actually are, and of course, what they are used for. So there are different widely used format string functions. To begin with, they are the printf family of functions. There is format that you might know, and there's the % in Python. And they are basically used to substitute placeholders in a string with actual data. And they are very convenient in most languages because they will automatically convert data for you to a string representation, and you don't have to do that manually, which is really a pain. And C, for example. So how are format strings used? I will give you an example. For example, here there is a printf function call, and there is a string and a parameter of the function, an additional one. So the string says there are currently %d people in this room, and the number of people. So if you execute that, you get there are currently 5 people in this room. And as I already said, it makes life a lot easier to do that. But it's actually prone to vulnerabilities if you use it incorrectly. And
hey, Sven, the
yeah.
%d, what's the syntax behind that for our audience?
There are different format string specifiers. %d means it's a decimal number. There's also, for example, %x that will print hex representation, or %s, which will print a string. And there are a lot of these ones, and some are responsible for vulnerabilities. So
Paul, remember. So Paul needs to remember this when he writes episode number is a string when it really should be an int or something like that.
Yes, I do that. I tend to do that a lot. Does it handle in Python? Can you do % and then have it handle none type?
I am not really sure. I'd have to look that up, actually.
I'll take that as homework as well. It's a good point.
Okay. So there's actually one root cause for format string vulnerabilities, and that is allowing user input as the format string. We've seen before that there was a string with the %d, and there was a variable that you would pass to the format string. And instead of using the string with %d, if you use user input, that's very dangerous. And how dangerous it is depends on the language you code in, as well as other factors we will talk about later. And in languages such as the C, format string vulnerabilities might even directly lead to code execution. There is a very interesting paper about that. I'll show you the link here. And it goes into great detail about C and format string vulnerabilities. I will explain a little bit about them. I don't do binary exploitation primarily, so I think it's good to get an overview. But if you want to get more details, then you should certainly read the paper. So these format strings are sometimes used as a way to print data back to the user. You would have seen a lot of it some while ago, before it was known that format strings are actually dangerous. And they are insecure because if you use the printf user input that you see above, that example is insecure because the user input is supplied as the format string. So variable and function parameters are usually stored on the stack. And when you supply a format string specifier such as %s for strings or %x for hex representation, printf will get their data from the stack and prepare it accordingly to use it in a string. So printf will grab exactly as much values from the stack as their format string specifiers most of the time. There are also exceptions to that rule, but it's generally how it works. And there's a problem. If you use the format strings correctly, this will correlate with the amount of function parameters that were passed to printf. However, if you use it as above, you will likely grab random data from the stack that the printf function thinks are actually valid parameters for printf. And you can even use the %n specifier to gain code execution. That is very interesting because the %n specifier allows you to write the amount of characters that were already printed to an address you supply to printf. And that also means, like, if you have the string here, hello %n, it will store the number 5 at the address you pass to printf. And if you control the format string and the address, that means that you can write arbitrary data anywhere in memory where you wish to do that. You just have to supply the address. And you can override return addresses, for example, variables, or the global offset table. And you might wonder if C is the only vulnerable language and are web applications secure. So there are countless languages you can write your applications in. C shouldn't be your number one choice, obviously. And therefore, there shouldn't be any format string vulnerabilities, right? But printf and other string formatting functions made it into other languages as well. They are not exclusively used in C. And the question is, are they secure? And we actually did quite a bit of research on that topic. And I will just show you how it looks in C to get a general idea of how such a vulnerability might look like. Here we print the current return address. You can see it here. I don't know if you can see it very good.
Yeah, that's better.
And this might be some user input that is printed here. You can use %p for a pointer, and that will print like here the 8 characters, the 8 bytes. And as you might see, you can actually leak the current return address here, or you can also override it if you know what it is, and all that stuff. I think that might be a stack address or something. I'm not sure. And so, as I said, we looked at different languages, and there is one very, very big surprise here. And that is, if you use PHP with the printf function, you're actually not vulnerable to format strings exploits. And that really surprised me, because if there's a vulnerability, PHP is likely the first language to implement it. But that wasn't the case here. So the reason why it's not vulnerable is that PHP will check the number of format string specifiers and the number of function parameters. And if they don't match, then there will be an error message and nothing else will happen. So the function isn't executed and the script will actually abort.
Yeah, it's interesting, Sven, whether they did that for security reasons or they did that for usability reasons to basically force programmers to correctly format the parameters to the printf function.
Yeah, I can hardly imagine that it is for security reasons. You're right. It's PHP after all. But I guess that's actually, like you said, it's for usability. And yeah, I think it's just the way that PHP handles stuff in general with the mandatory number of function parameters, etc. So Ruby was quite similar. It did the same thing. And now we get to Perl, and Perl is a little bit more vulnerable. So it actually also has a %n format string specifier. And it does basically the same thing as you would do in C. It will, for example, here we have first the variable string. This is a string, and then we do printf with 24a's and add in %n specifier and have the string as the second parameter here. And now if we would print string, it would actually print 24 because it was overwritten with the number of characters that were already printed. And there's a further problem, because the Perl comparison table, if you look at the integer 0 and any string, if both are compared, it will return true. So what I thought of was, if you have a format string specifier that you can use in a format string like that, that is user controlled, you could theoretically override something like a password that you specify, and you could turn it into an integer 0, and therefore pass checks like this check, for example.
So when Perl compares a string to an integer, you don't get an error; it just returns true.
Yeah, basically. And that was what I thought would be a really cool use case for it. Because you sometimes can't pass strings, you can't pass integers, you can only pass strings and the like. And then I took a closer look to the Perl comparison table, actually. And if nothing else shocked you on Halloween, then it's this. The Perl comparison table is much worse than the one of PHP. So even if you would pass a string with a string that contains the number 0 and compare it to any string, it will still return true. So that really surprised me. And I actually wrote that here because even the string 0 would work, and you wouldn't really need to convert it to an integer here or anything. But there's also the case that you might control the format string, but you don't control the parameters that are passed to it. And that is a really neat way to override them, for example, with a 0 or anything. And then you can abuse it further down in the code. So that is also a possibility to influence parameters that are actually not, you can't influence otherwise. So yeah, there's Lua as well.
Well, Sven, there was an important point there too. When you pass variables, typically like from the back end to the front end or get data, right? A lot of times it just converts it to a string, right? In a web application, sometimes it just removes the type and makes everything a string, correct?
Yeah, you really have to know about the language that you're using and how it will behave. For example, you might have seen that if you pass some data to a Node.js application, like it might return the square brackets with object inside, or just the string array if you use PHP. So there are some very interesting conversions, and you really need to know all about them to avoid vulnerabilities. in some cases, yes. So Lua was actually secure as well. It allowed a number of format string specifiers, but %n was not one of them. And it also checked the argument count. So that is also really surprising because Lua isn't very big. It's not that. I think it's intentionally very small, so you can use it in stuff like embedded devices, and routers and the like. I've seen it before.
Yeah, in OpenWRT, they a long time ago, I remember they switched to a Lua-based web application due to a small footprint.
Yeah, it has a lot of advantages for that use case, and it actually made sure that you can't use more format string specifiers than there are function arguments. So they thought it was important enough to include it there to make sure it's secure. And then we also have Java with the system.out.printf function. And again, there's a %n specifier, but it doesn't do what you would think it does. Instead, it will use an appropriate line separator for the platform you're running it on. So if you use it, it might either return /r/n, so CRLF, or just a line feed or something like that. But it depends on the platform you use it and what the appropriate line separator is there. And then we arrive at Python. It is also a very interesting case. And there are two different ways to format to use format strings. We have the one you can see here with the %. It's mostly used in Python 2, I guess. In older versions of Python 2, it was the only way to do format strings, if I remember correctly. And yeah, it's very interesting. %n is not supported. It is generally secure. And then the .format method came along. So it is a built-in method for strings. And you can see how it works here. You use these parentheses, and then you supply your formats there. And it even allows you to access properties of objects you pass to it, like you can see below. And it's very convenient. So you can actually pass an object like this, and then you can access the name of the object, the name of this particular object, which is Alice, and the age, which is 42. And this will print.
I didn't know you could specify a dictionary and then print out the keys, print out the values by key.
Yeah, it's very convenient, but there's also a problem with that. And I will explain to you now. So as I said, both of them will print Alice is 42 years old. But there's also a vulnerability here, because if you have a class like this, class person, and you, for example, in the init function, you will set self.name to Alice and self.age to 42. You can access that as well, and it looks great. It looks harmless. It's very convenient. But there's a big problem. As you can see, we have an API key variable here, which contains some string. And if we look further down, no, we don't. So the problem here is that you actually can access this init function here. I think it was somewhere below. Exactly, here's the payload. So you use person, the name we specified here, then we access the init function of person, we access the globals attribute, and then we can access the API key, because how that works is you will access the init function first, which is a user-defined function. And
yeah, and that's for those listening, not the visual reference, right? Where oftentimes we'll say dunder init, right, and dunder global or globals. Was it globals plural or
it's globals? I think. Yeah,
globals plural, right? Yeah, dunder init, dunder globals, and then that allows you to access any global variables, even though you only started with an object reference of something that was user defined.
Exactly, and these user-defined functions also have other attributes that might be interesting to you. If you use a blacklist approach, for example, like __doc, __, which would print you the functions documentation string, like a comment that is at the beginning of the function, basically. I don't know if there was any in the example. Let me check. No, there wasn't. But yeah, that's how it works. If there was some comment here, you would access it like that. And there are also other attributes you can access. It's very interesting to try that out and look at what you can actually leak in a blacklist approach, where you know that there's a format string vulnerability, but you don't know the variables on the server side, or maybe you don't know, or you want to know what the function does, read the documentation or something like that. So it's very interesting.
That seems like it's going to become a pretty big deal.
Go ahead, Tyler. Sorry.
It seems like it's going to be a big deal with all of the push to rewrite a lot of the code, and obviously people are going to be leveraging some of the new functions and features of the new formatting. I wonder if we're going to see a whole bunch of these kind of string vulnerabilities get introduced in the near future.
Yeah, it wouldn't surprise me, especially since you didn't have these concerns with the old style of doing it, with the percent between the format string and the parameters. And if you just would use user input before for a format string, that wouldn't do any harm, I think. But if you would just blindly replace it with the dot format, it would really lead to these vulnerabilities. And you really have to be careful if you rewrite your code to not introduce a vulnerability like that.
Now, Sven, when you're using the format method in Python and you're accessing object or referencing objects, is that specific to Python 3?
I think even in Python 2, I think Python 2.6 and above, it also is like that. You also have this format built-in method.
Mm-hmm.
At least that's what I read. I didn't try it yet, but that should work there as well in some versions.
I'm writing in Python 2.7, and I use the format method with double curly braces. I don't see any occurrences in my code, at least, where it's accessing any type of objects in the format method. So I'm wondering if that's a Python 3 specific thing or not. And to Tyler's point, as folks start converting from 2.7 to 3, or any version of 2 to 3, they're going to start using this new functionality, like Tyler, like you said, and potentially introducing a whole bunch more vulnerabilities if you're not careful.
Yeah, I think what you should do then is actually, if you have these vulnerable instances in your old code, it would really be a good idea to leverage or to use the format strings as they are intended, and use the user input you had in there before to as a parameter for a format string that contains, for example, %s in the place you want it to be. So yeah, I think there are some edge cases where you really need to have these user inputs there. For example, if you have some kind of translation or user supplied translation stuff like that, or any and anything like that. And in the article that we have linked in this post, I think it's maybe down here. No, there's an article linked here somewhere that explains it in greater detail.
Mm-hmm.
And
Was that the one you sent?
it
Yeah, this is the
actually
one you sent me.
yeah.
This is the one you sent me. Yeah, this was a very good article.
Yeah, it actually proposes a solution for that. That will throw an error if you try to access it like that. I'm not sure how good this advice is. I'm not primarily coding in Python most of the time. So I can't tell you if it's bypassable or not, but you could certainly look into the solution that was proposed and maybe check for yourself if it is sound or not, and if it works for you. And then you can maybe do that if you really need to use these user supplied format strings. What we also took a look at was JavaScript, and JavaScript does not need any format strings, really. So you could use the build and replace function, but that is frustrating and a little bit complicated. You can also use template strings, which are very, very good, in my opinion, because you just supply them in your code like that. There's no way you can do that by you can do that with user input. You really have to do that in your code, except if you use evil or something like that. But that is nothing you should do anyway. So how it works is you have these backticks here, and in the middle you have the string, and where you want to replace your placeholders, you use these $sign and the parentheses and just the variable name you have defined before, and it will replace those automatically for you. So it's really a secure way to do stuff. You don't have any function parameters here. You can directly use the variable names, and it is not possible for a user to supply something like that. And therefore, it is one of the more secure alternatives to the classic format strings, I would say. Exactly. There are some new problems that were introduced with these template literals. I think they're called like that. For example, you can just omit the usual parentheses here, and you can use directly the backticks, which was really really painful if you were a developer of web application firewalls and the like, or if you had a filter that would check if there is a function name and your request with the parentheses and then something. So these backticks really made it hard to detect for a while. And I think most of the commercial web application firewalls would catch that as well, or would catch it even earlier on the HTML level. There is also another interesting thing that you could overlook. The article was written when Google Chrome still had its XSS filter, and there are probably a lot of Chrome setups out there that were not updated yet. And if you had server-side code like this, printf user input ls 42 in PHP, for example, then you could just supply something like this code here, and the %s would be replaced by ls, which would confuse the XSS auditor of Chrome and then actually don't detect the cross-site scripting vulnerability that was there, and didn't detect that there were reflected XSS because the %s was replaced by ls in the response. Yeah, and that's about it. We concluded the blog post with a way on how to prevent these format string vulnerabilities, which I've explained before. You should really not use user input in the format string, but instead use the format string as intended and use the user input as a parameter. So if you're interested in that, you can check this this post on our Netsparker blog. And it's also a good idea to read the article about format strings that explains, for example, a little bit better than I did how the stack works and how it interacts with the printf function. And it's very detailed and very interesting. It's a bit old. I think it's from 2001. But there is still very much valid information in there that you could even use today.
Awesome.
So,
I think a lot of them are great examples that you want to include in your static source code analysis or in your linting to agree on a standard as to how you will use format strings in the language that you're coding in, and then put those rules into your linting system or static code analysis, so that everyone just kind of gets in tune with doing things the correct way that has the least potential to introduce vulnerabilities.
Yeah, I really agree on that one.
And I mean, treating user input, I think developers sometimes get a little sloppy with user input. That can be dangerous for a lot of different vulnerabilities. Tyler, Matt, questions for Sven?
No, made complete sense. At least there's a method for you to create a safe formatter in Python for PP work. So that was good.
Yes. Yeah. I actually did go through our code base and make sure we didn't have those style vulnerabilities. And I think because of my security background, I'm very, very careful anytime I'm handling user input to not redisplay that back out to the screen. And if I do it in such a way that the possibilities of it being manipulated are very low. Because in Python Flash, you've got Flash, but it's not Flash like you think of Adobe Flash. It's Flash as a function. That's how data basically gets spit back out inside the browser. There's lots of different ways to structure that. Also protections you can build in to make sure that you're not introducing vulnerabilities. So good stuff. Good. And so there's a couple of different links that we'll make sure get in the show notes. There's one for the Python post that Sven referenced, and then there's the Netsparker blog. So Sven, make sure we have both of those so we can put them in the show notes for this segment.
All right, sure.
Fantastic. Well, thank you, everyone. Thank you, Sven, Matt, and Tyler for this segment. With that, we will take a break and come back to conclude the show with the final segment where myself, Matt, and Dave, right? It is Dave, right? From Cyber. David Bittner from the CyberWire podcast. We crossed the streams and had a great conversation. So if you are a listener of this show and the CyberWire, you get to hear us hang out for a while. So that is coming up next, and we'll conclude this episode. So thank you.